Okay, we're live on Facebook and YouTube. All right, we have 56 attendees joining us so far. Welcome to you all. We'll begin shortly. All right, guys, so we'll begin very shortly, but in the meantime, we'll wait for a few more to give them a buffer period to join in. So what's new at One Stop Warehouse? Well, this is our second webinar of 2021. If you haven't seen our first one, we did a discussion on panel wafer size evolution, how they've increased over time. We're seeing that trend, and what's the consequential panel technology and dimensions and implications. So check that out if you're interested in that topic. Also, next week, we have Smart Energy Conference, Tuesday, Wednesday next week, and Thursday. I'm coming Tuesday to help set up. So it's going to be a good one. We have a lot of beautiful products coming, all the reputable major brands, panels, inverters, battery storage, you name it, it's all there. So feel free to come through, talk to us, talk to panel suppliers, inverter suppliers, to answer all your questions, and just to get a feel for all the new technology in the market. Furthermore, One Stop Warehouse planning a roadshow actually in the month of June and the early parts of July. We're going to be traveling to different states to perform a roadshow. Well, we will conduct basically a topic on energy storage. So where are we with energy storage in the Australian energy landscape, and invite a couple of energy storage suppliers like LG Chem, Sungro, and a few more, all of them coming from different backgrounds to give you an overall image about energy storage. Anyway, enough rambling. Let's begin with what we come here for today. So welcome everybody to One Stop Warehouse's webinar 2 of 2021. Today, we'll talk about the changes from the new AS477 and recently drafted AS5033 and what it will bring to the Australian market. So today, I've invited some guest panelists to assist me in this discussion. So basically, we've brought an array of solar industry stakeholders who have direct involvement in these standard changes. And basically, we have inverter manufacturers, panel manufacturer, and 2 very reputable solar retailers and installers. So let's introduce them one by one now. First, we have Glenn Morris from SolarQuip. And he's a celebrity, if you didn't already know, but I'll allow him to introduce himself.
Thanks, Ramsey. Yeah, a tiny celebrity. Yeah, I think YouTube has grown my audience a little bit, but mostly I'm involved in doing testing, field testing of products, training of installers, and I sit on the standards committee.
Awesome. Thanks, Glenn. Next up, we have Haider Khan from Huawei, inverter manufacturer.
Yes, Haider Khan here, the product solutions manager for Huawei. I have been with Huawei inverter business for the last 3 years now, and I'm responsible for translating these requirements into the product itself.
Thank you, Haider. Moving on, next we have James Sturge from Solaredge.
Hi, thank you very much. Yes, I'm the technical director with Solaredge, so I'm responsible for a lot of the product development, product compliance, policy, regulation. I also sit on a couple of standards committees and also very heavily involved with the Clean Energy Council as well from a policy and directorate perspective.
Awesome. Next, we have Mike Noski from Keppel Engineering.
Yeah, thanks. Thanks, Ramsey. We've been doing solar for 10 years now in Southwest Victoria and Goulburn Valley mostly. We've done maybe, I don't know. So we're a reasonably large rural solar retailer. We're doing maybe 400 homes this year and about 1 megawatt of commercial, I guess. So, yep.
Great. Awesome, Mike. Awesome to have you on the discussion. Next, we have Ian Gittis from UV Power.
G'day. UV Power based in Brisbane. We formed in 2009, a medium-sized business, but we try to keep ahead of the innovation and trying to sort of break new ground where we can. So we're mostly in the residential, but a few smaller commercial jobs as well. We're mostly focusing on car chargers, vehicles to grid, batteries, and sort of trying to move the industry forward as much as we can.
Great. And last but not least, we have Richard Quinn from Longi, Australia.
Thanks, Ramsey, and One Stop Warehouse to invite Longi. I'm very glad to be part of the discussion. I'm Richard, product engineer from Longi, Australia, mainly looking after technical support, product, and etc. Thanks.
Thank you, guys, and really awesome to have you on the discussion today. And as you can see, guys, we have the full spectrum of solar industry stakeholders to give their guidance and their angles of these new standards. So please also keep in mind, guys, that basically we hand selected all the major changes we found from the standards that probably hold the most value that you need to acknowledge. But of course, being a new standard, there's probably a lot of new changes that will come. And we're not going to get into the nitty gritty because they're obviously time constrained. But we did summarize the major changes you should know about, and we'll discuss it shortly. So without further ado, I'll begin. So first, we'd like to talk about AS47777. So where are we with this standard? So this was recently drafted, recently published last year in December 2020, and we're just in the observation period, and it's going to be fully implemented by this year, December 2021. So the purpose to talk about this standard is to summarize the major changes that will come to the market. And we also want to get an update on the timeline of inverter manufacturers certifying their products to this new standard, 2020 version. So get the current status update, and also what models as a result of this standard will not be recertified and CEC listed, so AKA discontinued. Also, from this new standard changes, what we can forecast in the future of the energy landscape because of this. So these are the major changes that I summarized. We've got 4 points to speak about. First one is the operation specification of inverter under different grid conditions is improved to ensure grid stability. So specifically, we want to talk about under voltage protection level. So there's been an amendment to clause 4.4, specifically passive anti-idling protective settings for voltage. So there's a new under voltage reference value of 70 volts with an associated 1 second trip delay time. And the existing 180 volts under voltage trip delay time has been increased from 1 to 10 seconds now. Furthermore, the over voltage has also changed. It's changed from 260 and 265 volts to 265 and 275 volts respectively. So what I figured from this is probably inverters now should have increased tolerance for under and over voltage in the power network to alleviate power network voltage variation, and ultimately increasing grid stability as we see more penetration of DER. So I'd like to pass this to Mike. What's your thoughts about this new clause change for under and over voltage protective settings?
It's got to be reasonable for customers, because the issues we have at the moment, under voltage is not such a big issue, but over voltage is a huge issue where the grids are running banging on 250, 253 volts right across a lot of rural Victoria anyway. And so we're seeing a lot of customers where their inverters spend half a day turned off because they're forever banging on the top of the voltage range. And it really creates issues then, especially in rural settings where farmhouses that are located back off away from the connection point, voltage rise is such a huge issue that it's not funny when the grid's running so high. So having the extra limits will be good, but whether or not that improves life, because the other consequences of all this stuff, I should say, is that the grids are increasingly giving us zero export in rural Victoria.
Yep.
We'd be seeing about 40% of our applications now coming back with zeros. Now, whether the grids then, the Power Core and the other distributors then increase their tolerance for voltage is another issue that needs to be dealt with separately.
Awesome. So we can all see this as a positive change. Cool. Moving on, speaking of distributors, moving on to the second major change, I'd like to speak about DNSPs. So there's a new standard that specifies the default power quality set points for volt response. So there's new set points been introduced called Australia A, B, and C. And you can look at clause 3.3.2 for that one. And I think this was introduced to help align all DNSPs and simplify this process. So as far as we know, the latest update from the CEC on the 15th of April, referencing agenda item 08 attachment 2, we see that 6 DNSPs have selected Australia A. No one has selected B and C, while currently the remaining 10 DNSPs in the country still have their own unique set points. So I'd like to ask James, given some uncertainty here, what solution or options will you provide from your end to installers when they are configuring these set points in your inverters during commissioning? Will you provide A, B, and C? Will you provide all DNSP set points, or what's the solution for you guys?
Well, as a mandatory requirement to comply with the standard, you have to be able to provide all of the various different options. But actually, as per, I think, the end of last week, all bar one DNSP in Australia has gone for Zone A. So there's only one, which I think is Evo Energy, which is yet to actually publish which set point they're going to go to. But the set points or the settings, the standardization of this is to make life simpler, but most importantly, it's actually to try to drive compliance, because one of the biggest issues that I have experienced and the feedback that I've had from a lot of the networks especially is that often it's been quite challenging for the networks and inspectors to actually know whether or not the systems have been set correctly. So what this is doing is it's going to take the onus off the installer to have to go through the details of volt watt, volt var, and all the other sort of very, very specific methods to set all those different parameters. And all they've got to do is select A, which is really, really going to help compliance. And also add on to that, the requirement to be able to provide those settings is a good one. So yes, everyone is going to have to provide all those different options to be compliant and to be able to be listed against the standard. Gotcha.
Okay, cool. So first point, increasing grid stability. Second point, increasing compliance. So safe to say both points are good changes. Moving to number 3 now, AS47772 2020 now introduces their own version of the VDRT, voltage disturbance ride-through test, in clause 4.5.4. And now it includes 4 voltage reference points, which align with the new voltage protective settings. And the CEC actually has taken over the VDRT approved inverter checklist. So you can view VDRT approved inverters from CEC website now, just to centralize that and make it easier. You don't have to venture somewhere else, I noticed. And okay, Hader, so compared to the South Australian Power Network VDRT, what is the differences, and is there much needed to be done on product for this 4777?
As far as our range is concerned, we don't have to do much. We are starting our testing already with the new standard. And I think it's with all other inverter manufacturers as well. Once you are able to do the VDRT for the South Australian requirements, and it will be a smooth ride for the AS477 2020 version.
Okay, cool. Good to hear. And last point, number 4. So we're seeing the increase of storage penetration and EV vehicle to grid charging in the grid. And in this new standard, they touch on the topic of this, increasing power quality for more energy storage. So Ian, I'd like to ask you, is this a good step forward, and what do you expect for this in the future?
Well, I see it as really future-proofing. So the AS47777 is looking to the future, which is also a very positive sign. I think where we're aiming as an industry is looking at electric cars will be the major automobiles in the next 10 years. So we've got to really prepare for that now. And so it's actually a good clause in there. So I suppose vehicle to grid, vehicle to home, and just a straight EV charger will be a big part of most households in the future. So planning for it now is important. I think what they're doing is a very positive aspect on our end. It also allows us to bypass the need for home batteries. When you've got vehicle to grid, I think home batteries won't be as needed as they will be. You've got a car battery there, which is larger and mobile, has more potential than a home battery. So I think what they're doing with this is actually very good.
Yeah, good point, Ian. Cool. Guys, feel free to ask any questions you have in the chat box or the Q&A box, and myself or any of the guest panelists will be happy to answer you. Otherwise, if you have a really urgent question you'd like to talk with us, you can raise your hand and we can speak to you. Cool. Moving on. CEC listing updates. So basically what happened now is the CEC has set the listing expiry dates for all current inverters listing which have compliance to the previous AS4777, the 2015 version, to 18th of December 2021 default. Now, if they have expiries beyond this date, they are set to this new expiry date on the 18th of December. If they wish to, after this date, inverters must be tested to the new standard in order to get relisted and extended expiry date beyond this date. So that's the update for that. If you're wondering why all the inverters on the CEC website are 18th of December, that's what happened there. So Hader and James, beginning with Hader, how's your product lineup and roadmap looking for listing all your products on the website?
Okay, so as I said, July onwards, we are going to start the testing with the lab, and we are expecting that all our existing product range will be certified by October, November. So it will be by time. So if you give 4 to 6 weeks for CEC as well, so it will be in time. Which models won't be relisted? The retired 29.9 and 36, which is overtaken by the M3 models, they won't be tested. The old 20 kilowatt version, 17 and 20 kilowatt versions, which are overtaken by the M2 models already, they won't be listed. Apart from that, all our fleet will be tested and relisted for 2020 compliance.
Awesome, Hader. Cool. Good to hear. James, what about you guys?
So yes, I mean, one thing I just wanted to mention is that the CEC listing, there's also a higher level of regulation that sits above that, which is that the AMC specify that compliance with 4777.2 is written into the national electricity rules, which then becomes a mandatory requirement on this date as well. So it's not just the CEC that are imposing this; actually comes much higher up the food chain, this requirement. In terms, though, of our product lineup, yeah, everything, the current forecast and roadmap is that all of our products will be fully tested, certified, and listed by the required point in time. We are in the current process already of retiring the storage products, which are going to be replaced by the Energy Hub. There is going to be some slight changes with the classification, because the way in which the CEC also at the same time is changing the categorization of products. So it's going to be far simpler for installers or inspectors or whoever to be able to identify the product and, most importantly, how it's operating. Because with if, for instance, you have a hybrid inverter with just PV connected to it, it works in one way. As soon as you put a battery on it, it has to work in different ways, especially when you're talking about things like volt var and stuff like that. So it's going to be much clearer, simpler, and yes, very confident that everything should be able to be listed and up on the new CEC site in time.
All right, awesome. So good news all around, guys. That's good to hear. And yeah, product categorization is very important as well, just to understand where a product sits. Cool. So moving on, now we'd like to move to AS5033 draft discussion. So purpose, once again, focusing on discussion about the main changes and topics and directly affected product changes as a result. So we look at the goods and bads due to the changes, and also I'd like to highly recommend leaving a public comment for any of the major changes we raised today or any other ones you might have in mind. And at the end of this presentation, I'll also just show you a quick guide how to submit this public comment. All right, so major change number 1 is the maximum voltage limit. So maximum DC circuit limit. So previously we've seen the 600 volts. Now the calculated maximum PV limit has been increased to 1000 volts for domestic / multiple domestic electrical installations. And in CNI, it's been increased to 1500 volts. So majority of people see this as a step forward, as it allows a bit more flexibility for both product and design. The most frequent feedback, however, I've seen is just to allow 1500 volts across the board. So I'd like to hear your thoughts about that. And also people complaining about the actual clause needs to more clearly define domestic. They want to reference specific building code classes instead of just mentioning domestic, because there is some unique scenarios out there where a particular premises is very hard to identify as domestic or CNI. So starting with Glenn, how good will this be for installations? Are you happy with this new clause?
Well, I think I've described this as the good, bad, and ugly draft. There's some great stuff in here. Like, we've been hanging out for this 1,000 volt increase for so long, particularly residential customers with 3-phase power. We just know that's a real challenge. It'll also make longer strings easier to install and give more options and flexibility to designers. But as you said, the problem does come down to things like definition. I think we dropped the ball, the committee, a bit on this one in terms of defining domestic. It's going to be an easy one to fix. We used to define it as type 1, 2, 3, and 10 under the National Construction Code. So I think that's probably going to be fixed in the public comment phase. But I think there's a kind of ancillary problem, which you're going to come to in a minute, which is it brings along restricted access to all PV systems up to the disconnection point. And so that's a bit of a change that, unless it's clarified, we're going to find this a problem for tilt frames and ground mount systems. So that's something that could be the bad part of going to 1,000 volts.
Yep, well noted, Glenn. Okay, so I already observed that the 3-phase Resi products are already capable of this 1,000 volts, but the single phase are manufactured and designed for 600 volts. So going to James and Hayder again, you know, what's your plans? Are you going to get your single phase changed, or are you going to progressively increase the input voltage, max input voltage progressively? And what's the plans? I'll start with James, sorry.
Yeah, thanks. So the short answer is that from a domestic, let's say single phase Resi product, going to 1,000 volts initially probably isn't the smartest solution. Really just around, if you start to consider maximum PV size and or the average PV size, let's say it's 6 kilowatts, you know, trying to bring that in at somewhere within a sweet spot of an MPPT that's around that. I just don't think generally across the board most manufacturers will see the need. I personally think that the main material benefit for this at an installation point is purely going to be the case that installers don't need to worry about doing temperature coefficient calculations anymore with that absolute cutoff at, you know, what does a panel do at -5, blah, blah, blah. Does it go at 602, therefore it's non-compliant? You know, that whole bit of the industry just goes away beautifully. As far as the products are concerned, like, it's going to be down to each manufacturer to work out what is the sweet spot for the maximum power point tracker. And, you know, it just opens up that 3-phase. yeah, absolutely. It does tend to make more sense, and it will mean that some of those, because at the moment, a lot of our three-phase products, which are generally sort of more of a global product, which would be sitting within that 1,000-volt DC window, we've had to adjust them to actually bring them down to the 600 volts. So it means that booster product, we can revert back to how it used to be and just go fine, 1,000 volts. Because often you'll find that a lot of, especially three-phase products, especially products used in Europe, they're already at 1,000 volts. So it's just going to probably, for most vendors, create a bit of more global alignment with other products that are out there. But that single-phase resi stuff, yeah, it's just going to be on that calculation side that it's really going to make the main difference to the industry.
Yeah, good point, James. I didn't even think about the design standpoint view. Now people don't have to worry about, oh, will my 15 panels, exceed the 600 volts? So that's a good point. And also Solaredge has been screwed around a little bit with that 600 volt in the three-phase. So I feel sorry for you guys.
Yeah.
Yeah. Hader, what about you guys?
Yes, similar feedback that I'm going to give here. Three-phase residential range, which is up to 1,000 volts. We have a very bit of confusion in the market that someone Googles the 8 kilowatt or 10 kilowatt three-phase Huawei inverter and downloads a data sheet from Europe. And they say, hey, this is a hybrid inverter. But we don't have a hybrid 8 or 10 kilowatt inverter in Australia because of the 600 volt limit. So we have the non-hybrid version 8 to 10 kilowatt here in Australia because of that limit. So we can have 2 strings per MPPT and get under that 600 volt requirement. But now with this scrapped, we can release our global model in Australia now. So it's 8 and 10 kilowatt hybrid inverter. So this is what we were looking forward to. Single phase, our maximum is 6 kilowatt. And we are coming up with larger single phase inverters, and that will go up to 1,000 volts. So yeah, if it's 5 and 6 kilowatt single phase, you won't be installing more than 1.5 times PV anyways. So that will go up to 1,000 volt, the larger single phase inverters.
Yeah, great, Hader. That's awesome news, because I think there's a lot of demand for the larger Huawei hybrids in the market. So that's good news. And that's what this standard has opened up for you guys. So positive there.
Yes.
Cool. All right, Ian and Mike, can I get your thoughts on this, especially from your standpoint? Very important.
Yeah, well, as a retailer, it's great news. So about a third of our installs are three-phase, and most of those three-phase installs are usually 10 kilowatt or 15 kilowatt inverters. So allowing that 1,000 volts will definitely allow the mechanisms of our designs and where we put things on roofs to be a lot more open, a lot more easy. So it'll allow us to sell bigger systems more often. So very happy about that, and it's good for the industry.
Great. And Mike?
Yeah, we do a lot of standard sort of 6.5 kilowatt domestic systems. 600 volts is no drama for us. But talking to the inverter manufacturers, and most of them have been telling me that their inverters are actually designed to 1,000 and they've just name tagged them to 600. So it's probably not the issue that I thought it might be for inverter manufacturers. But I think the better solution, Glenn, or something that needs to be dealt with, and that is that the definition of what's domestic against what building classes needs to be sorted out, because the 600 volts when you're putting solar on a nursing home is ridiculous. It's just far more complex and far more BOP than you need. So having the 1,000 volt for bigger systems on those class of buildings would be significant. But from that point of view, the 1,500 volt is neither here nor there. That'll happen, except that I think most of the smaller inverters in the country at the moment are rated at 1,000 volts, not 1,500 volts. So it's only going to be really, really big commercial and industrial where the 1,500 plays a sensible part.
Yeah, awesome. All right, guys.
You won't be finding many inverters converting 1,500 volt DC to low voltage, 400 volts. So
sorry?
You won't be finding many inverters at converting 1,500 volt DC to 415 volt AC. So I think that just putting that number there doesn't it might spike a bit of an interest for designers in the beginning, but they won't be finding any solutions in the market for low voltage connections.
The other issue is that most of the inverters, the sweet spot for the MPPTs, the 1,000 volt domestic isn't going to be much of a deal anyway, because you're going to be pushing the strings way outside the MPPT range. So it's just one of those things. Yep.
Good point, guys. Good point. So keen to see how that plays out. But once again, I think we should bookmark 3.1 to leave a comment on clarifying that domestic definition. So yeah, I want to point that one out.
I think that is important. Yep.
Yeah. All right. So moving on to major change number 2. So for PV cables, referring to clause 4.4.2.1b, mouthful, they must conform these cables to IEC 62930, international standard for 1500 volt rated PV cable. So basically, given this new CNI voltage, max voltage input to 1500 volt and this PV standard to 1500 volt, will 1500 volt become the new standard in CNI in the future? And will you retailers, not Mike and Ian, ask for 1500 volt rated equipment for your projects in order to save some costs on bill of materials, with those longer strings and whatnot? Or do you still see 1000 volt have a place in the market for the future? I'll start with Ian.
I'm not sure if it'll make too much difference in the domestic sense. In commercial, maybe, but where we are in domestic, probably not a lot of difference to our installs and the cost of materials. Small in the scale of things, so probably quite minor in our aspect, but maybe for different businesses.
Yep, cool. I agree with that. Mike, what do you reckon?
For the really big commercial, the sort of, if you have a look at western suburbs of Melbourne and places, 1500s are sensible, but 1000 volts is, for the commercial that we do, 60 or 70% of the commercial we do, you're not going to find roof spaces where you're going to have 1500 volt strings anyway. So I think 1500 volts got a place, but making everything else conform to 1500 when a lot of the systems are still going to be put in at 1000 volts. That's a question that needs to be talked about.
Yep, copy that. I've noticed a Q&A question come up from Daniel Hupert. When are these changes going to be officially enacted? Is in regards to this 1000 volt limit. So Glenn, I believe you've already answered this one.
Oh, yes. In fact, just maybe explaining the public comment phase for those who are not familiar with it. It's the chance for anyone at all, you don't have to be an industry professional, to make comments about this draft 5033. It closes on Thursday, as you've reiterated already, Ramsey, so you've got to get them in. The draft then goes back to the committee. All the public comments go to the committee, and every single one of them gets read and collated and either accepted, rejected, or modified. And so it's a really good opportunity to have impact on this standard. In terms of when will it become, well, I haven't got my crystal ball handy. It's somewhere out the back here, but it depends on how fast we go. So if this draft goes through without major changes, it's probably going to be this year. But if major changes are made to the draft as a result of public comment phase, then we have to go to another public comment phase, and that would blow it out to next year, I imagine. So really just hold your breath and see how we go. Probably late May is when we meet, and we should sort of have a clarity on whether there's going to be another public comment phase or not.
Yeah, cool. Thanks, Glenn.
Ramsey, can I just say, Glenn, finding copies of the draft is really difficult. I don't know whether it's particular to our solar system, to our internet system here, but whenever I go looking for it on all of the searches I've done, I just come up with a page not found.
You have to register with standards.org.au.
We are registered.
Registered, okay. And then it comes up, there's public drafts that are open.
Yeah, well, they're not easy to find.
All right, I'll follow up with you offline, Mike, to help you out.
Yeah.
Because I got a copy, and we can sort you out. All right, cool. Thanks, Mike, for the inquiry. Now, on the same topic of this cable standard, I'd like to ask Richard. Haven't seen you for a while. Where are you, Richard? Yeah, so are 1500 volt rated panels already existing? And do you think the panel manufacturers will make all panels 1500 volts? So, you know, it's already capable of 1500. It can cover 1000 volt and 1500 volt market. And as a result, will you keep 1000 volt panels? So I'm just wondering your thoughts on your products.
Thanks, Rams. Thanks for bringing that up. So from product side, I think we only keep the all black module as 1000 volt rated, and everything else is 1500 volt rated from LONGI's side to cope with different system size. And I think other major suppliers, they offer both 1000 volt and 1500 volt for same power class. But it could be an opportunity to see that more focus or supply could come from 15 volt rated panels. But still, it's hard to say because I think most STC jobs will still be 1000 volt. And even for LGC, especially rooftop jobs, that only accounts for maybe less than 10% of the total installed capacity. So, yeah.
Yep, awesome. And so what about MC4 and MC4 Evo 2? So this is a commonly asked question in the market. What's the differences? Are they compatible with each other? Can you just advise everybody for this?
Yes, currently I think it's been approved by CEC that Evo 2 can directly mate with MC4. And we also supply modules with Evo 2 connectors. But the supply of EVO 2 is quite tight and limited. So, for example, if we see an uptake in the 1500 volt system in the future, to secure the EVO 2 connector could be a potential issue. So, I think another better option would be to use the manufacturer specified connector, for example, the LR5 from LONGI, which is also equally reliable and it's been deployed globally in tens of gigawatt of solar systems. So, and also I think regarding the 1500 volt, another point I would raise is the PID could be a potential risk with a system with high DC voltage. So it's important to choose reliable and certified products, and maybe use inverter with like anti-PID module or functional earthing as well.
Oh, okay, good point. Yep, PID recovery. Okay, so already based on what Hayder said, I think I'll just get a quick answer for this one. Hayder and James, so will you release 1500 volt rated inverters for the future for CNI, like 100 kilowatt systems?
I'll jump in first. We already have a whole range of CNI inverters already built around the 1500 volts. So they're built around our optimizers, so we don't, it's not really, we're not currently planning to change any of the product suite. With everything from an input voltage perspective, the only thing that is currently under consideration is the option for the residential 3-phase to go back up to 1000 volts like it used to be before. We had to, reverse engineer it down to 600 volts. At the moment, we already have a full suite of products which are accepted and highly utilized in the industry. So there's no real need to change them.
Yep, noted, James. And Hayder?
So we have 1500 volt string inverters with 800 volt AC output. So that's for solar farms. Okay. Medium voltage connection, where you use a step-up transformer with it. We don't see this because what has changed? The previous 5033 wasn't mentioning any upper limit. Now they have mentioned a figure, 1500. That might be, a bit of a spike in interest when designing a system. Okay, I can save the DC cable cost here and do a longer string. But if you look into the market, you won't be finding inverters converting 1500 volt to 400 volts. And obviously you have to compromise on the efficiency. You can do that. You have to compromise on the efficiency of it, of the conversion.
Mm-hmm. Yeah.
And I don't see that we will be releasing something in the future for that wish list. Things might change if that is what is asked for and that's where the market is going. You never know. But I don't see in all practicality that this is going to happen.
Yeah, interesting. I'm keen to see how this plays out, because at one end you have BOS savings, at the other end efficiency losses, but it's all,
Yep.
fine line. So we'll see.
A wish list, yes. Let's just increase the wish list of the designer.
Exactly. Cool. All right, guys, moving on to major topic number 3. This is specifically talking about clamping zones. So clause 4.3.2.2.6, you can find this section. So feedback so far from public comment is this clause needs to be refreshed with a generic guide instead of referencing screenshots from, a current, commercial installation manual available. And also industry mentioning the clamping zones are a bit too strict for practical installation constraints like roof space. You might need to disobey the clamping zone to fit your rows of panels and whatnot. So I'd like to get your opinions, Glenn and Ian and Mike, starting with Glenn. How do you think, how do you find the clamping zones of solar panels these days? And with the panels getting slowly creeping longer and longer, what's happening?
Well, I think you totally have to follow the manufacturer's recommendations. They test them to a load based on clamping zones. You go outside of those, the product can't be warranted. So I can't see an out.
Yep. It's as simple as that. But sometimes I've heard some installations where it's just extremely minimal roof space and people have to get exceptions from manufacturers. So, okay. Ian, what do you think?
Well, I think manufacturers have been really pushing the limits with bigger panel sizes, including bigger footprints. It's causing a lot of problems. We have a lot of issues with the 370 watt panels, and now very soon moving into the 400s and the 420s. We're going to have larger and larger footprints on domestic roofs, and it's ridiculous. On a tin roof, you've got to have some specific batten locations, and we're using more 330s again. So we went from 370s back to 330s just to give us more space in those clamping zones. So the Australian standards looking at clamping zones, I think is a good thing. We do need to be within the manufacturer's specifications, but the manufacturers need to also give us the option of smaller panels. These bigger panels are not good on all of our installations, especially tin roofs, especially tighter tin roofs. The smaller panels are actually better for our needs, and I'm pushing most manufacturers to re-release 330s. It's a far better panel for our needs on domestic roofs.
What's the general spacing between these batten or purlin roof screw lines on the tin roofs, Ian?
Depends where you're located, but in Brisbane, I think we're around about the 900s. That does vary according to the house, but overall we're having just the 900s for the 330s are okay, but when you start to 370s, you are overhanging and missing a lot of the clamping zones. So we are looking at a lot of now running at the in landscape, and landscape, in my opinion, on domestic roofs doesn't look as good, and also it's just a bit of more of a trickier install also. Right.
Okay, so Richard, noting this down, what do you think of the current clamping zones of panels, and are they good enough, or can manufacturers in future, provide exceptions for certain roofs? Because in the CNI and some domestic, there's a big portion of these tin roofs.
Yeah, well, I think I would definitely agree with Glenn and Ian. So I think for us as a panel manufacturer, the only thing we can do is to make the clamping zone as broad as possible to bring flexibility to a customer. For example, the 370 at the moment, from 0 to up to 625 from the end of the frame, they're all rated at 2,400 Pascal. So it's quite flexible to cope with different roof types and batten widths. And also for this particular clause, I think the only comment from my side would be that, well, it says the solar module instructions shall be followed, but I think the mounting supplies instructions shall be followed as well, because For example, there are a couple of points listed here. In the D, it says the dimension. It mentioned the dimension of the underlying support beams, and in the E, it says that the clamp force specification for fasteners. I think most of the panel manufacturers only specify the torque value for bolt mounting because there is a direct contact between the bolt and the panel frame, whereas the clamp mounting, so I think it's subject to the requirement of the mounting supplier. So that's one thing I would comment.
Yeah. And Mike, what's your thoughts?
Oh, look, I think Richard summed it up. In the past, whenever we've had issues, we've gone back to the manufacturers and asked them if we can mount specific situations outside what used to be quite rigid clamping zones that were all written around 50-200 Pascal, which is snow loading. And inevitably, we were given written authorization to go outside, and then we just have to argue with the auditors. But the new Longy clamping zone diagrams are really good. They've got green zones for full 5200. They've got or 4800. They've got orange zones for 2400, and red zones that you shouldn't go into. So I don't think it's a problem at the moment. Certainly not in places where you don't have a snow load. It's been made to be a problem because the old clamping zone diagrams from manufacturers were just all written around the one set of rules. But yeah, I think what Longy's done is great, and that takes a lot of the argument out of the subject, and we struggle to find a place where we can't mount within those rules, within those diagrams.
Yeah, agreed. Longy, great work for that. Yeah, it makes life simple. So moving on to the next one now, guys. Quite a notorious topic because there's just much confusion on the clarity. So let's take some time now to talk about restricted access, clause 4.3.2.3.2. Basically, it's saying restricted access shall be provided to PV modules and wiring systems up to the disconnection point. So just much confusion for this clause, and people asking for clarity for more comprehensive definition of the restricted access, and for what type of systems as well, like a ground mount or or a tilted system on the roof. So Glenn, how do you find this, and could you clarify this clause in more detail?
Yeah, I think this is one of the ones that I put some comments in. It's ironic that I'm actually on the committee, but we're such a big committee now that we have 5 subcommittees, so we don't necessarily have visibility across the whole process until the draft comes out. So the problem I think it's here is that terminology now is that all PV systems within the scope, that's over 35 volts and 100 watts, restricted access up to the point of disconnection, or the disconnection point. Now, the disconnection point isn't necessarily a rooftop isolator. It's now capable of being a plug and socket on the roof. But the definition on those 4 A, B, C, and D definitions of restricted access are probably okay for your conventional parallel to the roof system where the cables are underneath the panels. So they're restricted by location. They're restricted by height. It's not the roof is 2.5 meters off the ground, it's the surface. So if you're standing on a roof, you're not 2.5, the wiring isn't 2.5 meters above you. But if it's underneath the panel, it's by location. I see the problem now is tilt frames. So you put a tilt frame on a roof, on a domestic installation. It's accessible by the owner. They get up there to clean their gutters. They can touch the wires, which are behind the panels, which are now deemed to be restricted access because the point of disconnection is after the plug and socket connections within the array. So yeah, I think this is a big problem. It's also a big problem for ground mount systems, not solar farms, but just your regular farm ground mount system. Are you going to have to put a barbed wire fence around your panels to maintain restricted access? So yeah, I think we need to work on this one. So there's quite a few comments already. I think there's 8 comments for this one already. So let's kind of get in there and make some. And can I just give a plug for be constructive in your comments. Don't say, I don't like it. That counts for nothing. Say, clearly what the problem is and maybe suggest a solution.
Yes, definitely a barbed wired fence would not look pretty. So let's be innovative guys here. All right. What about you, Ian and Mike? Have any comments on this? Starting with Ian.
I think Glenn summed it all up quite well. I think it definitely needs a lot more work, and we are now very much in the right location to make those comments. So yeah, get writing your submissions to the AS organisation to get changed and how you want it. So I think there, Glenn's exactly right. Yeah,
cool. Agreed. All good, Mike?
Yeah. If the point of connection is a plug-in that you need a tool to get the plug broken up, and I think this is an overkill basically. You can't go onto a roof and manually pull cables easily. I mean, you've got to really intend to do it. It's not something you can do by accident. So I actually think this is a huge overkill.
Cool. Good to hear your opinion. All right. So now, guys, let's move on to the one you've all been waiting for. The ones we've clickbaited you with, I guess. Nah, okay. They're all important, but this is another major change that I'd like to talk about. So basically, okay, are rooftop DC isolators gone forever on roofs? Short answer, no. What is the requirements not to use them? Well, there's three things you have to consider. First one is to refer to clause 4.3.3 and navigate to the decision tree, which is illustrated here on the screen. Now, this runs you through all the different scenarios which you may have and advises at the end of the decision tree whether you need or do not need the DC isolator on the roof. Secondly, if you don't use a DC isolator, you have to use these new associated signage, which is step 2, labeling rules. And step 3, if you don't use a DC isolator on the roof, you also have a new requirement for how you route your cable on the roof eave or the roof attic. Basically has to be, installed like 600 mil above the ceiling, not laid down to the floor of the ceiling. Just like the diagram here, I've illustrated here. Once you get 1 meter from the external wall of the house, then you can drop it down to the ceiling. Otherwise, 600 mil gap. So yeah, it seems to be a great change. As we've seen statistically, the most common point of failure in the solar PV system on the roof is actual rooftop DC isolators themselves. They're burning out or catching fire. Just can't stand the mother nature. So however, there are still criteria which I just mentioned to be met. So yeah, Glenn, please tell me your thoughts. You're part of this committee as well.
Well, actually, this was my baby. I was the work group leader for DC isolation. So, so I tell you what, when I was told, do you want to do it? I go, yeah, I'm going to get rid of the rooftop isolator. I kind of had a motivation there. And I thought it would be pretty damned easy. Our first meeting, I kind of said, okay, guys, let's just adopt the New Zealand solution that's already in 5033. Because the New Zealand solution is exactly this, just a point of disconnection that's labelled on the roof. And they've been doing it for ages. In fact, the New Zealand safety regulator rejected the Australian approach of a rooftop isolator based on the experience of Australia, catching fire and failing and poor installation methodologies, counterfeit product, all of that. But it wasn't that easy. So as often when we relook at a solution, other people's kind of inputs make it more complicated. So we had to deal with the issues associated with emergency services and isolation of cables within a building. And that's where this extra drawing, step 3, the special wiring rule came about. Now, a little bit of an explainer here. You'll see there's all these different measurements now. A wiring system installed above 600 mils distance from the ceiling. And there's a zone where you can drop below that at 1.5 meters. You can drop below that 600 mils if it's attached to the roof structure, and within 1 meter of the outside wall, you can drop right down to the ceiling. That's all about the way fire services deal with building fires. They often will pull the ceiling down with a big hook. And so they just wanted a little bit of confidence that if they stayed 1.5 meters away from the wall, they could poke a hook through and pull down the ceiling without pulling down a whole bunch of DC cables with it. So that was the intent. But you can completely avoid this 600 mil rule if you put in a rooftop isolator. So for any, you've always got that option to go back to a rooftop isolator. Yeah.
Yeah, cool. So I see a question from Michael King. So before I answer, let's go through these exemptions of when you don't have to use the rooftop DC isolator, and hopefully that will answer your question. So basically, when are you not required to install one? Basically, if you have up to 2 strings in parallel, you don't have to install one. Any more than 2, then you will require. And the second exception is if the inverter has a fuse inbuilt in each string, or has an external combiner box with fuses, and coupled with a compliant DC isolator on the inverter itself. So when you're paralleling strings and the DC isolator is compliant and there's string fusing, then you don't have to install a rooftop DC isolator. Those are the 2 scenarios. So anything to add, Glenn? Did I describe that properly?
Very good summary. I must admit, this standard is pretty hard to read, so your clarity's been most helpful.
Cool. And does that answer your question, Michael King? Please let us know on the chat box. Cool.
Is the standard going to clarify when you can use DC isolators in inverters? Because that's a major area of confusion at the moment.
Yeah, I agree, Mike.
That's covered in 4777.
No, the issue is that there's 4 different sets of auditors now doing audits, and some states allow the use of DC isolators in inverters, and some electrical inspectors approve it, but some of the auditors won't allow it.
Yeah, but as long as the DC isolator is listed, is certified, compliant, tested, listed on the ESS site, with ERAC, then it's compliant. And in some scenarios, you have to list the inverter.
No, that should be the situation, but it isn't.
Yes, some inspectors have their own interpretation, and so I came across an inspector who was saying that it should be padlocked. Secured in open position means a padlock can be inserted.
Yeah.
So.
And some of the auditors, I believe in particular the CER auditors, refuse to accept it.
Yeah, I mean compliance, and the general.
But they're claiming it doesn't provide you with an isolation of the cable through the system if you remove the inverter. So the standard needs to resolve that and set some rules that then we can all follow.
Yeah, I agree with that, Mike. I've seen that come up quite a few times.
That was addressed in the Amendment 1 and Amendment 2, 5033 2018 version. So
yeah, that's what I thought.
Yeah,
it's a training issue for inspectors.
Yes.
It's not a standards issue.
Yep.
There you go. Yeah, so some auditors have to catch up, I guess.
It's a governance issue, really, that at the end of the day, that you have all these different inspectors that can interpret things differently, and that there's nowhere really within the industry that anyone can go to find the single source of truth. It all comes down to different interpretations of fundamentally the same rules. And it's always been an issue. And until there is some fully robust governance structure to go to, this issue is going to just keep going around in circles. I mean, whether it's to do with DC isolation or other aspects of standards, it's all a governance challenge.
Yeah.
Maybe then you need, Glenn, the standards committee needs to have a look at the things you've written, because if there's interpretation issues, then maybe you need to just have a look at the way they're written. But
Mike, inspectors are one of my favourite courses to run, because there's quite a few of the DNSPs have got me to run courses for inspectors. Because remember, many of them have never done solar, never been accredited for solar, know the wiring rules inside out, and then just kind of do their best to interpret it.
Yeah, it's not so much inspectors as auditors, I find. Anyway.
Yeah. All right, guys. So just being conscious of time, we'll just keep moving on. Daniel Huppert, how often does anyone do 3 strings in parallel for Resi? Well, I'm not sure, but just judging by products alone, everybody's using multi-MPPTs these days with a max string input of 2. So you will not find yourself in this scenario often. So that helps the first criteria of not using rooftop DC isolator of up to 2 strings in parallel. Nobody will probably exceed this in many scenarios. However, one scenario I do think of is actually from James. The Solaredge design topology, actually, you're running these strings in parallel and combining them in a combiner box or however they want to do it, and then connecting the PV cable to the inverter. So what's your thoughts, James, on your design?
Well, the ideal is to do a single string, because that's what we can do regardless of orientation till module type. That's the beauty of Solaredge, is that you can just do up to certain, there are obviously boundaries you have to fit into in terms of maximum system size, but for most residential single phase systems anyway, single string is fine. It's very rare to get into a 3-string scenario within a residential setting. Very, very rare. But if it is the case, then even with the parallel strings, just apply to the rules. Just apply the rules. And in some situations, like Glenn says, depending on the roof type and construction, it might actually be easier and simpler to put on a rooftop isolator. So it's kind of horses for courses. I don't see a huge amount of issue within this. It's actually just giving installers a bit more choice and a bit more freedom, I think, anyway. Well, that's how I read it. But like anything, there's always the catches.
Yes, and even your single string design rule extends to your 10 kilowatt models. So you can do 2 strings and still you can get away with that and still install without a DC isolator if they please to.
Yeah, correct.
Okay, cool, guys. Next one is the last one, major topic change number 6. Not much content to discuss here, just more so just discussing in general for the future, because in this standard, they touched on rapid shutdown or automatic rapid shutdown. So, what's your guys' thoughts on this? And do you see this as a feasible, practical, and economical solution going forward for solar installations? I'll get everybody's opinion, starting with Glenn.
Okay, I think there's kind of 2 avenues we're going to be going down in terms of rapid shutdown. It's module level power electronics, whether that's DCUs or microinverters or arc fault detection. Both of those systems can ensure a certain level of safety, but we didn't address it in this draft. So that's something, as you say, may well be a game changer going forward.
Cool. Hader?
Well, we were expecting that some sort of alternative safety measure will be put in the draft when we are replacing rooftop isolators. So because, benchmarking international standards, the American standard, UL 1699B has it, has AFCI there. Then we have NEC as well. Then AFCI available in the IEC 62027. So we were expecting some sort of AFCI or rapid shutdown might be an alternative to rooftop isolators, but I can understand it's only 2-3 players in the market doing this at the moment. So, well, the other manufacturers are catering for the European and American market, so they can also come up with, there's a requirement in the standard, they can also come up and provide solutions for it as well. But I think we have to wait for the next update on it. And then we will catch up.
Cool. Ian, what's your experience with rapid shutdown?
Not a lot, but what I do believe, if it's going to replace anything to do with rooftop isolators or have anything to do with taking rooftop isolators out of the mix, rapid shutdown is a winner.
Yep, agreed. James, of course, you guys are, very strong in this.
Yes. From a safety perspective, rapid shutdown is absolutely awesome. I mean, it does create such a positive win for the industry where it's applied properly. We are very hopeful that either rapid shutdown or arc prevention or a combination of both in the near future can be incorporated into standards or rules or something, because they do offer so many better scenarios and solutions to a lot of the current restrictions within the standards.
Yeah, cool. Mike,
It's beyond my pay grade, mate.
Okay.
I'll go with Ian.
Let's study it together. Cool. Richard?
I think it could be a big thing. From our side, I think we're also looking at develop a smart module with integrated rapid shutdown and other function. But yeah, it could be there is a big space and potential in that.
Beautiful. All right, I think this is the last major change, if I'm not mistaken. Yep. So guys, just as we announced many times throughout the webinar, how to submit your comments, public comments for the AS5033 draft. Simply go to the standards website. So the link is here. And then basically you just have to register. Very simple, name, last name, email. Once you have an account, you just search 5033 in the standards. And once you get there, you get the screenshot you see on the screen, snippet of table of contents, which is all the clauses in the index form. You find the clause you want to comment about. When you find it, you can just click comment on the bottom right-hand corner. And from there, it will be on the forum online, your comments. So somebody can drop that link. That would be helpful in the chat box for everybody to have quick access. I don't think I can paste it from the presentation. No. All right. So I'll paste that at the end. So basically announcing again, reminder, Smart Energy Conference next week from the 12th to 13th of May. We'd love to see you there, have a chat, talk about products, talk about design, engineering, anything you like. Happy to have a chat and just have a nice networking opportunity as well after the pandemic last year. Good to see everybody in person. So I'll be looking forward to that one. All right. I'll stop sharing my screen. Now, thanks again, once again, to all the guest panelists for coming today and contributing to the discussion. Really appreciate it. So thank you. And do you have anything else to add? Glenn?
Oh, no, I just appreciate One Stop Warehouse for raising awareness around the draft and encouraging people to make public comments and clarifying some of those points. So well done, One Stop.
Thank you, Glenn. Yeah, appreciate it. And we're always happy to help and be not just a box mover, but your second-hand man when it comes to products, design, everything regarding solar. We want to help you guys. So thank you. Hader.
No, thanks for organizing a very good discussion, and especially thanks for having capital engineering and UV power here as well. Very useful inputs from these guys who do the work and apply these standards in practical.
Absolutely, yeah. I love getting all these different stakeholders together for discussions like this. Awesome. All right. Let me quickly get that link for you guys. And I'll just paste it in the chat box now. So everybody check out the chat box. And from there, you can toggle to the website and make your public comments. So I'll put it now. All right, can everybody see it? Awesome.
Yep, got it.
All right, guys. Well, that's it from me, from One Stop. Thank you again for joining the webinar. I really appreciate your views and hopefully you took value from the webinar. Cheers, guys.
Yeah, thanks for organizing it, guys.
Thanks, Ramsey.
Thanks a
Thank
lot.
you.
Cheers.
Cheers.
Good job.
Yeah,
Thank you.